Just want to start with a quick review of what we did on Friday in sketching and finding coterminal angles. So I've given you all of the original angles in examples 1, 2, and 3. I've put them in standard position, meaning their initial side is on the x-axis, their terminal side is what gets rotated, and their vertex is on the origin. They're in radians, so we're going to stay in radians. And remember, if we have a positive angle, we subtract 2 pi. We're thinking about opposites, going in the opposite direction to get the angle that is coterminal with it, meaning they have the same initial side and same terminal side. If it's a negative angle, we're going to add 2 pi. As in number 3, we have the negative angle. Then we'll use an arrow to show the direction of the coterminal angle. Take a look at 13 pi over 6. That's really equivalent to 2 1/6 pi. Gives us a better look at that. Remember, 2 pi goes around the circle one time. It's equivalent to 360 degrees. So I have to go all the way around once and then a little bit. That's what that 1/6 pi is showing. At 1/6. So I'm going to take 2 1/6 pi. I'm going to subtract 2 pi. And that gives me 1/6 pi, which we normally just say pi over 6. That is our coterminal angle, that if you notice where I showed my arrow, where it starts from the initial side to the terminal side. So we use the blue arrows, and notice in both of those we're going counterclockwise, which is the positive direction for positive angles. Number 2, we have 3 pi over 4. It's less than half a circle, which is 180 degrees or pi, so I'm showing you that as a reference. So I'm going to take 3 pi over 4 and subtract 2 pi. Common denominator there is 4 over 4. So I have 3 pi over 4 minus 8 pi over 4. And that gives me negative 5/4 pi, or 5 pi over 4. That's our coterminal angle, and I start from the initial side of the angle, go in the negative direction, which is clockwise, to the terminal side. And that's the coterminal angle to 3 pi over 4 is negative 5 pi over 4. Now in number 3, we have a negative angle, so it's going to go clockwise. It's less than pi. Remember, pi is equivalent to 180 degrees, a half of a circle. So there's my original angle we're starting with. And this time we're going to add 2 pi. We need to do the actual addition. So the common denominator here is 3, so I'll multiply 2 pi by 3 over 3. Gives me negative 2 pi thirds plus 6 pi over 3. Which is 4 pi over 3. So my coterminal angle here is positive, so I'm going to start from the initial side when I draw my angle, my arrow, to the terminal side in a counterclockwise direction to denote a positive angle. In this next example, recall that complementary angles in geometry have been defined as positive angles that add to 90 degrees. Well, pi over 2 is equivalent to 90 degrees. So to get the complement, you take the pi over 2, subtract the angle that you know to get the other angle. So here I'm just getting common denominator of 10. So I multiplied pi over 2 by 5 over 5 and 2 pi over 5 by 2 over 2. It gave me 5 pi over 10 minus 4 pi over 10 equals pi over 10. For the supplement, angles that are add up to 180 are supplements, and they have to be positive. And remember, 180 degrees is equivalent to pi. So I'm going to take pi and subtract the angle I know, which is 2 pi over 5. My common denominator is 5, so I'm going to multiply pi by 5 over 5 to get 5 pi over 5 minus 2 pi over 5. That gives me 3 pi over 5. So my supplement to the angle 2 pi over 5 is 3 pi over 5. Let's do it again. We're going to have a little issue with 4 pi over 5 though, and I want you to see what happens. So recall that 90 degrees is the same as pi over 2. So when I get that complement, I want to take pi over 2, subtract the angle I know from pi over 2. We're going to need a common denominator here, and it's going to be 10 again. So multiply that 4 pi over 5 by 2 over 2, the pi over 2 by 5 over 5. I get 5 pi over 10 minus 8 pi over 10, and that is going to give me negative 3 pi over 10. We'll look at the top where it says complementary angles are positive angles, and I just came up with a negative angle. So this situation is actually not possible for the definition that was given. Even though we can have negative angles in trigonometry, when we talk about complementary angles, we want them to be positive. So these complements must be positive in order for them, the angles must be positive in order for us to label them as complementary angles. Let's deal with the supplement. of 4 pi over 5. Again, 180 degrees is equivalent to pi, and all supplementary angles add to 180 degrees. So we're going to take pi minus the angle we know, 4 pi over 5, to get the supplement. Common denominator is 5, so when I multiply pi by 5 over 5 and then subtract 4 pi over 5, I get pi over 5. In this slide, I just want to show you how we're going to do the conversions in the last two slides. So we know that going all the way around a circle is 360 degrees, which is equivalent to 2 pi radians. We're going to let rad equal radians to shorten that up. If I want to figure out what 1 radian is, I can divide the above equation by 2 pi on both sides. So rewriting 2 pi radians equals 360. If I want to know what 1 radian is in degree form, divide both sides by 2 pi. The 2 pi's cancel out, and we're left with 1 radian equals 360 and 2 reduced to 180 over 1 pi, so 180 degrees over pi. So 1 radian is equivalent to 180 over pi. That's our first conversion. Our second conversion is to figure out, well, if we know what 1 radian is, what's 1 degree? So we're going to take that same equation above, the 2 pi radians equals 360 degrees, and we're going to divide both sides by 360 to get 1 degree, to see what that's equivalent to in radians. So when I do that, the 2 and the 360 still reduce to 1 and 180, so I'm left with pi over 180 radians equals 1 degree. So that's my second conversion we're going to use. Now let's do some examples for each. I'm going to convert the following degrees to radians. So I'm going to use the top conversion. To go from degrees to radians, you're going to multiply the degrees by pi over 180 radians. So take 135, multiply it by pi over 180. And in this case, when you're finding a greatest common denominator, you have to get the highest one. This one happens to be 45. If you didn't get it that the first time and you still see that those numbers can be reduced, just reduce it again. So 45 goes into 135 3 times, and it goes into 180 4 times. So once I simplify that, I get 3 pi over 4 radians. Let's look at 540 degrees. Doing that again. Want to convert to radians, so multiply it by pi over 180. 180 actually divides into 540 3 times, so I get 3 pi radians is equivalent to 540 degrees. And the last one is negative 270 degrees. Multiplying that by pi over 180, 180 and 270, 90 goes into both of those. So I get negative 3 and 2, give me negative 3 pi over 2 radians. In the last slide, we're going to convert from radians to degrees. So we're going to use the second conversion where we multiply the radians by 180 over pi. So starting with A, negative pi over 2 radians, multiplying that by 180 over pi. The pi's neatly cancel out. 2 and 180 reduced to negative 90. And so negative pi over 2 is equivalent to negative 90 degrees. In B, taking 9 pi over 2, multiplying it by 180 over pi. Again, the pi's neatly cancel out. The 2 and the 180 reduce to 1 and 90. And 9 times 90 is 810 degrees. For 2 radians, we're going to multiply by 180 over pi. And I'm not going to have pi's that neatly cancel out, so I'm going to multiply across to get 360 over pi for my exact answer. And then I can just put that in my calculator to get an equivalent of 114.59 degrees. So this is the last of the examples for the first half of section 1. So this is 1.1b. Please refer to these if you need to see them again. The nice thing about a video is you can watch it over and over again. And we'll do some checking for understanding in class to see if you guys are okay with this. But it's here now, and it'll be on the website for you to look over.